A warm welcome to one and all. So I am Pankaj Bajaj, leading Data on Cloud CEO in Tech Mahindra. In today's world, global enterprises looking forward to enable data-driven decision-making process, and modernize a data platform is key to success. Today, we will be discussing what challenges does the customer have with their traditional data architecture and how modern data architecture addresses those challenges with cloud-based cutting-edge tools and technologies. So our guests for today's session are Suresh Akena, who is a principal Worldwide GTM Leader Analytics for AWS. And we also have Saurabh Jha, who heads global data and analytics from Tech Mahindra perspective. So welcome you, both of you. So let me start with asking to Saurabh first. So Saurabh, according to you, what are the key market trends on global data platform across the industries?
All right. Thanks, Pankaj. So what we are seeing is, especially for the last couple of years, there is definitely a focus on the whole concept of data mesh. And when I say data mesh, in theory, I think we all understand what data mesh is: domain ownership, domain own governance, and so on and so forth. But it's not that the implementation across different organizations is similar, right? So the approaches are very, very different. In some cases, for example, it's about creating a semantic layer at the top of all of their data assets, and then kind of distributing or creating different views or different ownership, I would say, buckets for different domains. And here, for example, the ownership still kind of is shared between the domain as well as IT to a large extent. And there is a lot of centralized governance, but then there is, business, there is the data governance part is still with business, whereas the quality aspects are still taken care of by IT, right? So that's one. Other is there are a lot of organizations who have taken much larger steps, and they are very, very keen to go into a pure data mesh kind of a framework where they want a clear separation between the data, the way it is sourced, the way it is controlled, the way it is accessed, the way it is secured and governed, all the way from upstream to downstream, line with business, where the business has to take control not only of the data, but in certain cases, and what is known as harmonized mesh approach, where they want them to take control of data as well as the infrastructure behind it. So that's one trend, the whole data mesh trend, identifying use cases across different business functions, and then creating what we call as data products, right? So data products and providing it as a service. Now, again, these data products, that's another very big trend. Whether or not there is data mesh, I think this whole concept of data products is spot on, that is a good, valid, and a modern way of sharing data between different functions, between different domains. And that kind of leads to the next trend, which is how do you ultimately share these data products, right? So I would go even a step behind that as to how do you identify these data products. So in a lot of cases, what we have seen, for example, is customers or organizations just thinking that, okay, this is my entire set of customer data. Let's say, let me divide it into 20 different sets of data based on certain parameters, demographic data, the sales data, support data, and so on, and call them, data products. However, more mature organizations are doing it a little differently. What I mean by that is, they first identify what are the use cases for different types of data across the organization. So let's say, for example, if it is customer data, they would go around and bring all the other business functions onto the table, whether it is risk, marketing, sales, production, R&D, whatever. And they will understand very clearly as to how do each one of them want to use customer data for their respective functions. Same goes for data from the other parts of the organization. For example, say marketing data or production data. So again, they go to different business functions and identify how do they want to use the production data or R&D data or marketing data and so on. Once all of these requirements are kind of finalized, then they rationalize that entire requirement and create the definition for these data products, right? As to how many customer data products will be required, or how many minimum customer data products will be required, how many minimum R&D data products will be required, what should be contained in those data products, right? So that's how it is rationalized, and then they go on the journey to actually create those data products. Now coming back to the serving layer. So how do you serve these data products to the different domains? One is, of course, through your standardized, whether it is in a query format, web query, web service, and so on. Other is API, via APIs, which I believe is a better way, and which is something that there are certain organizations, they have taken the whole API first way of doing things. Whether it is on the whether it is around applications integration, whether it is around serving the data products for whatever consumption. It could be machine learning, it could be BI, it could be dashboards, whatever it is. So that's another way. So that serving layer has become very, very important, right? So that's another trend. So you had data mesh, data product. Third is traditionally, again, a lot of businesses who are especially large and complex, it's not that they had a centralized data warehouse. A few did, most of them had multiple data warehouses. There have been cases where we have seen more than 100 data warehouses across the organization, right? Which every business is built for their purpose. So these were purpose-built data warehouses. So this whole concept of a unified data platform has become very, very common, bringing all of those data warehouses onto a single platform, which is more powerful than all of them combined, number one, from a processing standpoint, which is much better at scaling, which is much better at serving, right? And when I say serving, it's not just technically serving, but also serving different purposes. So whether it is real-time analytics, whether it is, as I mentioned, machine learning, whether it is experimentation, whether it is self-service BI, and so on and so forth. So that's another major trend. Third is, and it kind of fits into the answers I spoke about earlier, but the whole concept around data monetization. Now, when we say data monetization, it is not necessarily only external monetization. So we know data monetization that, okay, you sell your data, anonymized data, you remove the PII information and you share it to a third party to earn some revenue. But data monetization is not just that. In fact, a majority of implementations globally around data monetizations are internal use cases. What I mean by that is where you enhance your revenue using your data. You create a completely new revenue line or a service line, creating that particular using your existing data. You increase your upsell and cross-sell effectiveness. You improve your operational effectiveness using your data. All of these have dollar value attached to them, and that is the kind of data monetization effort that that we are seeing across the board. And now, with and one other thing, what we used to hear earlier was primarily around self-service BI, right? Now today, and that is still a trend. It's people have had mixed successes in terms of implementing it. Now we are looking at the same thing from a self-service AI perspective, where again, so while creating a kind of an AI platform which is seamless with the data platform, an enterprise scale AI, bringing in things like ML ops, model ops, and so on and so forth. But at the same time, also being able to create pipelines which can serve this layer very, very well, and hence create an ecosystem of self-service AI for the different business functions across the organization. And finally, and of course, I think it's still a trend which is upcoming, but definitely catching up, is this whole thing around how will generative AI impact the entire data platform and data analytics value chain, where people have been experimenting with cognitive search on the data. So basically simplifying the whole reporting layer using cognitive, using large language models and generative AI and so on, to make it, so like, we were talking about self-service BI earlier. So can that be simplified further, using a large language model, and also the usage of large language models while the customers are on their journey to data modernizations, whether it's legacy code conversion and so on and so forth. So these are a few trends that we have come across frequently across different customers. Suresh, would you like to add a few points here?
We saw it like similar to Saurabh mentioned. We have basically like unified data governance. We see this, a lot of customers wants to build unified governance. Third one is deploy purpose-built databases with the best price performance. The last one is using AI ML to solve the business challenges. In terms of details, just data lake and analytics perspective, this is more like breaking silos and bringing unified data together, and that actually helps customers. This is like basically helps to customer finding data, discovering the data, and also enriching the data and processing large volumes of data, analyzing it, and also the more beneficial. It actually more beneficial to the end business use cases. For example, the greater amount of the data actually you have, like, customers have to store, manage, and process. That's much beneficial for a public cloud implementation, like with infinite scale and resources. What we've seen is once the data lake is established, and customers can have repeatedly consume the data with the low cost, with the high scalable performance, the services. Basically, they can interoperate the data sets across the analytical services. We have a purpose-built databases. They could use interoperate the data sets across analytical services. One of the benefit we see it is data has gravity. Basically, like if you see this, the more gravity you have, it's very hard to move the data across the organization. So having a unified data lake or like data mesh architecture, customers will be able to move the data across these services and optimize their workload to meet their various business use cases. It could be business intelligence, self-service analytics. It could be machine learning use cases, or it could be processing massive amounts of big data analytical use cases. Depending on the use case, you can interoperate the data sets within the data lake or like data mesh architecture. And the second thing is unified governance perspective. We see it, particularly like every person in the organization, they should have access to the data, and they should have the right people have access to the right data within the organization. That's what we believe it. That's what organizations thriving for democratizing the data within the companies, and they wanted to establish the data governance with the scalable data governance with the security controls, auditable, basically auditing and then compliance requirements. What we've seen is customers are often it's extremely difficult for them to striking the balance between maintaining the governance controls and also giving access to data. Customers are really struggling to that. So AWS perspective, I think we do have, we introduced a new service called Data Zone. I think the Data Zone will allow, it's a management service which will allow you to strike strong governance and also access controls. You will be able to catalog data, discover and share data across the producers and consumers within the data mesh architecture. The third one is deploy purpose-built data services, purpose-built analytical services for best price performance perspective. Organizations, like a lot of organizations, like either in the large enterprises, government agencies, and startup companies, they've been using purpose-built analytical services to optimize their workload to meet their different use cases. So in terms of AWS perspective, we have I think if you think about it, for example, if you have a mobile application, we have a document database to meet your high scale performance. Or if you have for example, if you want to build the graph database, so graph database allow you to present, explore connections between the title records, and same thing for machine learning. So the last one is, the use ML and AI to business challenges. This is more from the organization perspective. This is a kind of trend in the latest trend. A lot of organizations, whether the organizations, they want to improve customer satisfaction or optimize their productivity, or if you think about scale, speed up and scale the innovation, the organizations are looking to adopt AI ML services to meet the business needs. For example, if you think about we have a lot of unstructured data found in audio files, video, and then you have the text files, unstructured data, or earning transcripts and reports. What we can do is basically instead of giving human resource to go through these thousands of documents and come up with an insights, you can put together the ML model which will go through these thousands of documents and will generate structured data. On top of that, you can build an applications. I think that's where a lot of customers are employing AML services to go through these enormous amounts of data, running training the models, go through this enormous amount of data, unstructured data, finding insights, and then making business decisions. I think these four trends we see it in the field from AWS standpoint. Thank you.
I have further question to you. Now, what are the typical challenges customer face in their traditional on-premises data architecture?
Yeah, thanks, Pankaj. That's a good question. So what we see is when we are talking to customers executives, oftentimes we see it the first leverage we see it the data growth. And then the data is basically growing unprecedented rate, and you're talking about basically it's growing from terabytes to petabytes, sometimes it's zettabytes, and rapidly growing data, and managing managing different types of data is extremely difficult. On-premise infrastructure, data infrastructure is extremely difficult. That's first one is handling data growth in a scalable fashion, and the second one is AS infrastructure. We see this AS infrastructure on premises. Basically, those AS infrastructure doesn't support the modern advanced analytics and ML models to scale and support various business needs. And then third one is data silos. We've seen these organizations, they tend to have multiple business units or multiple business owners in different lines of businesses. They have basically the data is very pervasive, and data is manufactured, produced transactional systems, data warehouses, or Hadoop systems. It's basically across the enterprise. You see these various systems. It is very hard to put together a unified picture and generate insights. If a customer wants to have customer 360 and looking at holistically across these data sources, putting together customer 360 is extremely difficult. So the data silos is another thing, and then another thing is we see is the data gravity. We talked about it. So especially the data gravity piece is basically the data gravity means to us is basically if you have lots of data and it's very difficult to move across the systems. That's where is a data gravity. As data grows, it's very hard to move. Customers are like generating terabytes and petabytes of data, and with the on-premise infrastructure, they are not able to move between the systems, and not able to support the various business use cases. And then the last one is inconsistent data governance. This is where the security and compliance comes into the picture. We've seen this, customers are continuously putting together basically piece governance controls to support tactical business needs. Over the period of time, what happens is basically it becomes the access control becomes to scale, and also like there could be violations like the regulatory violations, and sometimes it could be non-compliance.
What are the reasons why the architecture was as it was? And for example, things like whether it is AI/ML use cases, streaming data, unstructured data, those things they were not able to handle. My question is, can the on-premise, whatever platform you set up, can it keep pace 5 years, 10 years down the line? So the answer to that, I believe, is a no. And I'll tell you the reason for that. I mean, at least the way I think. See, on cloud, what it really helps with, so in addition to giving you all the tools to create a modern data platform and a modern data architecture, is the speed at which you can change it. So today, for example, I'll give you a simple example. We had generative AI come into the larger picture just 6 months back, right? And almost all the cloud providers, all hyperscalers, have services built around it, which enterprises can start using today, right? So, and this is not a very long time, and most of them had the services available a couple of months ago. For a technology that that was so cutting edge, so advanced, making it available for anyone to use it within 4 months, that is speed. And what we have seen traditionally, especially in on-premise situation, is that whenever there is something new, it takes a huge amount of time to bring it into your architecture, replace certain components, integrate it with your entire ecosystem. So that speed of change and that flexibility of change, I think that is something, if you ask me, that is the biggest advantage of being on cloud.
Now, I'll again ask you, Saurabh, right? So what are the key pillars according to you modern data architecture should have? While defining or designing a modern or implementing a modern data architecture, what are the essential pillars of modern data architecture so that the design should be robust enough, scalable enough, and cost effective enough in the future?
So if you ask me, I mean, I know this is not a technical pillar, but a very important pillar is don't dump data in a central place without knowing what you're going to do with it. Like that, I think is very, very important. I mean, we've got lost in this quagmire over the last 20 years. And I think this is the right time to kind of put an end to it. What I mean is, whatever platform you're designing on whichever system, using whatever tools and technology, has to be business driven. If while you are creating your modern data architecture, you don't know the end use cases, most likely, two things may happen. Yes, you will probably create a very big lake or a lake house with lots of data, but the ROI, you will never see the ROI. Okay, if you try to start finding the answer after the fact as to, okay, now what should I do with it? That's number one. So it has to be, the design has to be business driven. For example, we always, a lot of technocrats get stuck in the whole debate on data fabric, virtualization, data mesh. It's not a technical decision in the first place. It's a business. It's actually a decision that has to be driven by business and the organization itself. If it is a simple organization, do you need to create a data mesh architecture? Probably not. If your volume of data is less and so on. Yes, if you're a complex organization, each of your business functions are very, very powerful and so on, absolutely makes sense. So these design decisions have to be business driven. Second thing, a modern data architecture has to, now coming to the technical aspects, has to account for all kind of consumption patterns that will be required, right? So I'm talking of, and let's say when we talk about real-time analytics, for that you will also have real-time sourcing. So it needs to take care of that. Second, if you have BI and dashboards, then you'll have to figure out the best way that the architecture is able to serve data in order to create those BI and dashboards at a fast speed and at whatever pace that is needed. For example, if it needs to be refreshed every 5 minutes, every 1 minute, every day, every month, whatever the case may be, right? Third thing, in terms of, again, sourcing and consumption, the places where you source from is going to only keep on increasing. Yes, we have seen a lot of edge cases where data is coming in from your mobile phones, from IoT devices, and so on. And trust me, over the next 10, 20 years, there'll be many more such newer areas from where data will keep on getting sourced. Different kind of data, like you talked about data variability. So data variability, velocity, it'll just keep on adding up. So your architecture has to be flexible enough to plug in these new sources and the variability of data as and when it comes. I mean, you can't again you create a new architecture 5 years down the line. I mean, this is not a 5-yearly exercise. So right now, when you are designing, the architecture should be able to take into account that tomorrow there could be a different kind of a data and a different kind of a source. So your pipeline should be designed in such a way that can take that into consideration. On the consumption side as well, today we have BI analytics, we have AI, machine learning. You need those playgrounds to experiment with different kind of machine learning models and AI. Now you have generative AI. Tomorrow you will have general artificial intelligence. You will have super intelligence, and all of that, mind you, all of that, including things like metaverse, which today is still a niche, but tomorrow it could be big. We don't know whether in its current form or in a new form or mixed reality. All of that will be on your consumption side. They will all need data at different velocities, different kinds, different way of serving them. So your data architecture has to be flexible enough to do that in the future.
So Suresh, according to you, what are the key pillars you think in the modern data architecture, and according to you, which one is the, or maybe one or two most critical one, right? Which will be form a core foundation of a modern data architecture.
Thank you, Saurabh and Pankaj. I think Saurabh touched a wide range of topics. I think the flexibility aspect and scalability and architecture components. I think he touched pretty much in a wide range of topics. First thing is, definitely, I think the scalable architecture, like whether it's like scalable data lakes or scalable data mesh architecture pattern, depending on their use case, they should look into this. You're unifying the entire the data sources, keeping in a single the single place like a data lake or data mesh architecture, and then establish governance controls. These governance controls are going to vary from industry to industry. That is the most thing. For example, if you go to financial industry or healthcare or government agencies, they're really concerned about regulation and compliance requirements. But go to other industries like media and entertainment and manufacturing, they're really concerned about scaling. They're really concerned about real-time decisions, if a machinery fails, or autonomous vehicles decisions, like accidents. It's not about regulation or data governance there. It's about speed, and it's about decision making. So when you're building an architecture, you need to keep in mind which industry you're designing it and what kind of use cases you need to support that. So as Saurabh mentioned, starting from near real time, ingesting data near real time, storing in the data lake, and we need to think about purpose-built analytical services or purpose-built AML services, because one size does not fit for all. That is number one. And the second one is data governance based on the industry. That's what always because sometimes if you work in government agencies, the compliance is going to break this whole architecture, like federal compliance or GDPR rules. You have to keep in mind your architecture, how you support these these compliance requirements, and how we can extend it. Those two are big things for me, actually, the scalable architecture and governance and compliance requirements. That's what I believe in it. Of course, scalability, performance, cost, and all those things. And besides these two things are a focus, actually.
Now, let me come back to my last question to Suresh first. Now, from your perspective, right, Suresh, what are the different customer scenarios you come across while implementation of this modern data platform? Can you brief a couple of them so that we will understand what are their challenges, the implementation, and what are the different problems they come with? You try to solve it.
Yeah, sure. We, the few customers, one of the customers is I think a Fortune 500 customer. They're a fintech customer. Fintech customer wanted to build basically the data production services, like a surveillance program. They wanted to detect any fraudulent transactions that are happening in their application continuously. Basically, they have various use cases for each fraud, and they wanted to continuously monitor the different types of fraud cases, the fraud for fraud transactions, and catch that, and also they would like to track any login attempts or malicious activities within their applications. They want to do a combination of both. We've seen these customers they have 26 microservices they built. This is fintech customer. This is a fintech heavy customer and Fortune 500. They have a 26 basically a microservices. Each microservice, they have a dedicated data lake, and then within the data lake they run the bunch of surveillance queries against massive amounts of data to detect any fraudulent transactions or fraud is happening or malicious activities happening. So that actually, like, that's actually allow them in this, for putting together modern architecture, like, the data lakes and data mesh architecture combination, allow them to make, basically, make, decisions faster. And also they're segregating, these, the types of use cases that they're segregating. They build the 26 data lakes. They're like, basically massive scale. They're running use cases in everyday. They run like, millions of queries or millions of patterns. They run it, and they try to get the insights.
Okay, thanks, Suresh. So, Saurabh, according to you, can you give brief examples? What are the different customer scenarios? And what are your differentiation? While implementing the modern data architecture for some of the customers.
Just in the data analytics space, most of our customers have multiple technologies. So, remember I had mentioned earlier that one of our customers, they had over 100 data warehouses built over the last 6 to 7 years. And the funny part is, they are in all of them are in different technologies. So they're not a particular, say, a Terra data warehouse or a cloud data warehouse or whatever it is. So they're all of different technologies, different databases, different data warehouse types. That's number one. So when we go in, I think one major advice that we give is whether you're in the future, even whether you're going for one single lake and lake house, or if you want to get into a harmonized mesh structure where you want to provide your businesses with their own lakes, whatever the case may be, try to unify the underlying technology, right? At least as far as data analytics is concerned. That's number one. Number two, now, getting the data warehouse and data lake out of the way. The second part is what are the other tools and technologies surrounding it for data quality, for data governance, for MDM, and so on and so forth. Now here, of course, there are a lot of players out in the market across all of these areas, including things like, say, data observability and various other aspects of data, things around data transformation, for example. There's some really good new tools. Then you have tools around data ingestion. Of course, you have the leaders from which have always been there. Plus, you have newer players in this area as well. Then on the general data pipeline management. Now, again, some of our customers, they have certain tools and technologies which are already in place, whether it's for quality governance, MDM, whether it is for privacy access management, whether it is for their data ingestion pipeline, data transformation, and so on. So in most cases, if these tools and technologies, and if our customer has invested in them for a very long time, and they're very intricately connected with their applications and can work with a cloud ecosystem, we try to keep it. Okay, we try our best to include them in the architecture. Because, see, modernization does not necessarily mean that if there are 20 different aspects to your architecture, you have to change everything. That's not modernization. I mean, if those tools have been modernized, have been continuously modernized, if they can work well in a cloud environment, why not? Let's use them. In cases where that is not the case, then our approach typically is use as many cloud native components as possible. So, like I said, most hyperscalers, including AWS, and others, they have native components for most of the data analytics value chain, right? If you look at the entire value chain of data analytics. So in cases where we do have to replace certain traditional tools and technologies, then our approach is to keep it as much as possible, keep it as cloud native as possible. What I mean by that is cloud native tools and technologies as possible. So that's number two.
Thank you, Suresh and Saurabh for today's session. The thoughts were very insightful, and thank you very much for discussion.
Thank you. Thank you, Pankaj.
Thank you. Thanks so much, Pankaj.
Bye.